Hello students, today we are going to discuss problems in alternating current. An alternating current changes from a complete cycle in 1 second, 1 microsecond. Then the frequency in hertz will be. What is frequency? Frequency is number of cycle per second. See here, in 1 microsecond, it is changing the direction. Okay, complete cycle in 1 microsecond. So frequency will be equal to 1 upon 1 micro means 10 power 6. This is frequency, hertz. So out of 4 options, the correct answer is option 4. Frequency means number of cycles per second. So option 4 is the correct answer. The RMS value of alternating current is 10 ampere having frequency of 50 Hz. RMS value is 10 ampere, frequency is 50 Hz. The time taken by the current to increase from 0 to maximum and maximum value of current will be. See, this is the diagram of alternating current. This time is from 0 to, this is T by 2 because this is complete cycle. So this time is T by 4. So time taken by alternating current in reaching from 0 to maximum is T by 4. And what is time period? Frequency is given 50 Hz. Time period equal to 1 upon frequency. This is 1 upon 50. What is value of 1 upon 50? If we write 100 into 10 power minus 2 divided by 50, this will be 2 into 10 power minus 2. And what is maximum value of current? Because RMS value is given 10 ampere. So maximum value is RMS into root 2. This is root 2 is 1.414. So this is 14.4 ampere. So the correct answer is 2 into 10 power minus 2 second and 14.4 ampere. So out of 4 options, the correct option is answer 1. If the frequency of alternating potential is 50 Hz, then the direction of potential changes in 1 second by. Since frequency is given 50 Hz, this is called 1 cycle. In 1 cycle, direction of potential changes 2 times. In 1 cycle, 2 times direction of potential changes positive to negative. Okay, 50 Hz means 50 cycles per second. In 1 second there are 50 cycles, means 100 times direction will change. So dear student, out of 4 choice, correct choice is option 2. So we will take answer 2 as correct choice. If the frequency of AC is 60 Hz, the time difference corresponding to phase difference of 60 degrees. In the question, frequency is given 60 Hz and we have to determine time difference when phase difference is 60 degrees. This is the relation phase difference upon 2 pi equal to time difference upon t. And what is time period? Time period can easily be calculated t equal to 1 upon 60 because this is 1 upon f. Okay. So what is time difference? Phase difference in the question is given 60 degree. 60 degree means pi by 3. This is 2 pi. And this is t. This is 1 by 60. After solving this equation, we will get pi will get cancelled. So this is 1 upon 360. So time difference is 1 upon 360. Okay. This is the answer. So out of 4 choice, the correct answer is option 4. Out of 4 choice, the correct answer is option 4. If the RMS value of AC is IRMS, then peak to peak value is. This is peak value. This is also peak value. Dear student, peak to peak value means 2I0. And what is I0? This is root 2 RMS. So answer to the question is option 3. Sinusoidal peak potential is 200 volt with frequency 50 Hz. It is represented by the equation. Peak value of voltage is 200 volt, frequency is 50 Hz. So equation can be written as omega will be equal to 2 pi f and f is 50 Hz. So this will be 100 pi, pi is 3.14, this is 314. So E equal to E0 sine omega t. This is our equation. So we can say peak value is 200 volt, 200 sine 314 into t. This is the solution to our question. E equal to 200 sine 314 t. So out of 4 choice, the correct answer is option 2. In the given figure, the potential difference is shown on R, L and C. The EMF of source in volt is. In AC circuit, there remains phase relationship between voltage and capacitor with resistor. Okay. Here voltage drop at resistance is 30 volt, at inductor it is 60 volt and voltage drop at capacitor is 100 volt. So EMF of the source can be written as V equal to VR vector plus VL minus VC vector. Okay, or VC minus VL, okay, whatever is more. So V equal to what? VR square. In this equation, VC minus VL ka whole square. This will be the case. So dear student, this is 30 square. VC is 100 minus 60 whole square. 30 square plus 40 square. 900 plus 1600. This is 2500. So this is 50 volt. So out of 4 choice, the correct choice is option 3. Which of the following figure showing the phase relationship is correct? Phase diagram for an RC circuit. The important thing that circuit is which type? This is RC circuit. In case of RC circuit, everyone knows that current leads the voltage, and cos phi equal to R upon Z. And what is Z? This will be less than 1. So value of phi should be between 0 to 90 degree and current should be lead. Okay. So out of 4 choice, in trigonometry angles are measured in anti-clockwise direction. So out of 4 choice, the correct choice is option 4. So option 4 is the correct answer. The vector diagram of the current and voltage in a given circuit is shown in the figure. The components of the circuit will be, anyone can see that voltage is leading the current by a phase of 45 degree. In inductive circuit, voltage leads the current. So either this can be LR circuit or this can be LCR circuit. So the option is option 3. Out of 4 choice, the correct choice is option 3. The power factor of the following circuit will be, in the circuit AC voltage is given 200 volt, frequency is 50 Hz, XC is equal to 40 ohm, R equal to 40 ohm, XL equal to 100 ohm, and internal resistance for L equal to 40 ohm. Okay. Dear student, if we draw the phasor diagram, this will be like this. This is VL minus VC and this is VR. This is V. This is phi. So if we find 10 phi here, this will be XL minus XC divided by R total. So XL minus XC in the circuit, this is 100 ohm and this is 40 ohm. So this will be 60 ohm. 100 minus 40, this will be 60. And R total, this is 40 ohm and this is also 40 ohm. So this is 80. After solving this, we get 3 by 4. So phi will be equal to 37 degree. And power factor is cos phi. So cos 37 degree is 4 upon 5. This is 0.8. So out of 4 choice, the correct choice is option 4. Out of 4 choice, the correct choice is option 4. In pure inductive circuit, the curve between frequency f and inductive reactance 1 upon XL is. In pure inductive circuit, XL equal to L omega. This is L into 2 pi f. So XL proportional f. So if we draw the graph between 1 upon XL and f, so definitely 1 upon XL will be proportional to 1 upon f. Okay. If you take this as a y, so y proportional 1 upon f. So this graph will be hyperbola. Okay. Because if f increases, y decreases, means 1 upon XL decreases. So out of 4 choice, the correct choice is option 3. Option 3 is the correct answer. The impedance of the given circuit will be, the resistance is given 150 ohm, inductance is given 200 ohm. What is impedance? Impedance can be written as R square plus XL square. So this will be 150 square plus 200 square. Take 0, outside this is 10, 15 square plus 20 square. If we solve this, this is 10, 15 square means 225, 20 square means 400, this is 625, 625 means this is 25, so this is 250. This is 250 ohm. So out of 4 choice, the correct choice is option 4. In an LCR circuit, the voltage across the components are VL, VC and VR respectively. The voltage of the source will be, when components remains R, L and C. In AC circuit, always some phase relation is maintained between R, L and C. So V can be written in vector form like this. V equal to VR vector plus VL minus VC vector. So fine. Input voltage VR square plus VL minus VC whole square. This is the relation. So out of 4 choice, the correct choice is option 4. Option 4 is the correct answer. In a certain circuit, E equal to 200 cos 314t and I equal to sin 314t plus pi by 4, the vector representation will be. See, this is cos component. So we can convert into sin component. E can be written as 200 sin 90 plus theta. Okay, this is the conversion. If we compare phase of voltage with the phase of current, we will see that voltage is leading by a phase of pi by 4, pi by 2 minus pi by 4. Okay, voltage is leading. When in trigonometric angles are plotted in anti-clockwise direction, since voltage is leading, so out of 4 diagram, the correct diagram is option 4, option 1. Out of 4 diagram, the correct answer is option 1. Option 1 is the correct answer. Because voltage is leading the current by a phase of pi by 4. If R equal to 100 ohm, then the value of X and I in the given circuit will be. Dear student, X remains equal to XL minus XC. Because here, voltage drop at inductor and capacitor are same 300 volt, 300 volt. Okay. And R at R voltage drop is X volt. Okay. So VL minus VC is 0. So voltage drop, this will be equal to 220 volt. Okay. So X should be 220 volt. And what is current? This is resonant circuit. Current will be equal to 220 upon resistance. This is 100. So this is 2.2 ampere. So out of 4 choice, the correct choice is option 3. This is 220 volt. So answer is option 3.